Welcome! Today we are cracking open one of Python's most powerful tools to see what makes it tick. We're talking about the dictionary and its incredible, almost magical speed.
So let's just jump right in with a puzzle. You've probably felt this, right? If you've ever worked with a ton of data in Python, you know that searching for one item in a massive list it can take a second. But grabbing a value from a huge dictionary, it feels completely instant. So what's the trick? How is that even possible? Okay, let's really break this down. Over on the left, you've got a list. To find anything in there, Python has no choice but to go through it one by one. It's asking, is this the one? Nope. How about this one? Still no. That's what we call a linear search. Think of it like looking for a specific book in a giant, messy pile. But a dictionary, that's more like using a library's card catalog. You go straight to the exact spot you need.
Now, if you were to build your own dictionary from scratch, the obvious way would be to just use a list of pairs, a key and a value. But then you're right back where you started with that same slow one-by-one search. So Python is clearly doing something way, way smarter under the hood. And the secret isn't some super complex code, it's actually a basic property of how Python objects work.
So, before we can get to the speed, we have to talk about one of the most fundamental concepts in Python, mutability. It's this great divide that splits all Python objects into two camps.
First up, we have immutable objects. And the name really says it all. They're unchangeable. Once you create something like the number 10 or the string hello, that specific object sitting there in your computer's memory can't be altered. It's set in stone.
To really see this, we can peek behind the curtain. Every single object in Python gets a unique ID, which is basically its memory address. So, when we create the number 10 and point our variable x to it, it gets a permanent spot in memory with a unique ID. Now watch what happens when we change x to 11. Whoa, look at that ID. It's completely different. We didn't actually change the original number 10. What Python did was create a brand new object, the number 11, at a totally new address, and just repointed our variable x to that new thing. All right, so on the other side of that great divide, we have mutable objects. And you can probably guess what that means. These can be changed. You can modify them directly, right where they are in memory, without creating a new object. Let's run the same experiment with a list, which is a classic mutable type. Here we've got a simple list with the number 1 inside. And just like before, it has its own unique ID, its own spot in memory.
But now, for the big reveal, let's add the number 2 to our list. And look at the ID. It is exactly the same. See? We didn't create a new list. We reached into the original object and changed it. We mutated it right in its place. That is the fundamental difference.
So why does all of this matter? Why do we care about changeable versus unchangeable objects? Because this distinction is the absolute key that unlocks the dictionary's speed. It's what makes the secret ingredient, a thing called hashing, possible.
Dictionaries use this process called hashing, and you can just think of it as a super efficient filing system. When you want to find something, a dictionary doesn't search at all. Instead, it takes the key you give it, runs it through a special mathematical function, a hash function, and that function instantly spits out a number. That number, or hash value, tells the dictionary the exact location, the index, or the slot, where it can find the value you're looking for. It's not a search, it's a direct calculation. The string Anna goes in, and boom, the number 0 comes out, pretty much instantly. And that index that gets calculated points to a specific slot in an internal structure, which we usually call a hash table. Here's what that looks like. The key Anna gets hashed, and the function says, put that in slot 0. So its value, C, goes right there. Eric hashes to index 3, John to 15. The important thing here is that there's no need to check slots 1, 2, or anything in between. Python just jumps directly to the right spot every single time. That direct access is where all that speed comes from. And this right here, this brings it all together. This is the big aha moment. Dictionary keys have to be immutable. Why? Well, think about it. The hash function's output depends on the key's value. If you could use a mutable list as a key, and then later you changed that list, its hash value would change too. The dictionary would then go looking for the value at the new hash location, find nothing, and the original value would just be lost. an orphan floating in the hash table with no way to ever find it again. Okay, that makes sense. But it also leads to a really good question. What happens if two completely different keys just happen to generate the same index? I mean, the number of possible keys is basically infinite, but the number of slots in that table is limited. So eventually, two keys are going to produce the same hash value, and that's called a hash collision.
So what does Python do? Does it crash? Does it overwrite the old value? Nope. It actually has a pretty clever way of handling this.
Let's say, in this example, the key Eve also hashes to index 0, right in the same slot as Anna. All Python does is store both of those key value pairs at that one location, usually in a tiny little list. So when you ask for Eve, Python first hashes to index 0, sees there are a couple of items there, and then does a super quick check. Is it Anna? Nope. Is it Eve? Yep, here's your value.
And this brings us to performance. On an average day, which is pretty much every day, a dictionary lookup happens in what we call constant time. All that means is that it takes the same amount of time to find an item whether your dictionary has 10 things in it or 10 million. Now, in the extremely, extremely rare worst-case scenario where a whole bunch of keys collide into the same slot, performance can slow down to linear time. Then it has to search through that one slot's little list. But honestly, Python's hashing algorithm is so good that this almost never happens in the real world.
Okay, let's bring it all home. Lists search, one by one. Dictionaries calculate. That calculation, hashing, turns an unchangeable, immutable key into a direct memory address. And that is precisely why you can't use a changeable, mutable list as a dictionary key. If its hash could change, the whole system would break.
And here's the real takeaway. Knowing the why behind the speed gives you a superpower. It lets you write faster, smarter, more efficient code. The next time you need to check if an item exists in a huge collection, you'll know instantly to reach for a dictionary or a set, not a list. So now that you know the secret, how is it going to change the way you build things in Python? That's it for this time. Thanks for watching.